Okay, so today I'm going to focus on data visualization and some basics, and I'm modifying a presentation I give on communicating data to non-expert audiences. And we'll talk about how to work with some basic visualizations in the GCC. And specifically we'll talk about tables, bar graphs, and line graphs. Now, you will frequently see some very complex data visualizations in the GCC that I think will just be beyond what you can really work with. But this will give you some basic principles to kind of work with these things, especially for more simple arguments or arguments that are intended for a broader, more public audience. So for instance, we have a concentration at CMU called Engineering and Public Policy, EPP. One of the things that people in EPP need to do is to make their arguments clear, not just for engineers, which they typically can do, but for politicians, policy experts. So that's one clear case where somebody needs to simplify some visualizations. So what I'm going to focus on is thinking about data visualizations as telling a story. This is a form of argument. I tried to stress this in the article that you read last class period. It's a form of argument. You're telling a story. And scientists actually use the word story all the time. I hear this, so it's part of their vocabulary. So you can go ahead and use this with students as you're working with them. Now, the three basic visualizations I'm going to focus on here are tables, bar charts, and line graphs. Now, let's talk about the pros and cons of each of these. Tables are really good for showing a lot of data, for showing a lot of detail. So they're good for capturing lots of data for precision. To capture trends, if the story is a trend, bar charts are really good for showing differences between groups. We'll come across this bar chart in a little bit, but we can see that the blue group is lower than the red group. Line charts are really good for capturing change over time. So line charts are generally, and if you see a line graph that is not used for time, you might want to question whether that is the most appropriate visualization. And they're really good for capturing a story of a trend. All right, so let's go ahead and focus on telling the story of your data. And I really want to hone in that visualizations tell a story. And we tell this story with both visuals and words. So this is, you've seen this study before in some of the materials. So this is gastric ulcer patients who received ranitidine alone versus those who received triple therapy. Obviously the story, the trend, this is the rate of recurrence. So this is the trend. We see that this goes up. This stays pretty flat. That's the story. Now we need, and students often don't put this in words. We need to clarify that staying flat is good. Honestly, when I first see this graph, my first thing is like, oh, well, it goes up, so that's the good one. So we need to put this in words to make sure that people don't have this misinterpretation. Because, of course, getting an ulcers increasing is a bad thing. So here's a quick headline: triple therapy reduced ulcer recurrence. This is a really good example for like a scientific poster. If this were in a journal article, we'd want to say something like, we'd want to label here and say figure 1, triple therapy versus ranitidine, and figure 1 shows that triple therapy reduced ulcer recurrence. But that is the main story there. Okay. All right, so let's take a look at this for a second. what is the main story? This is a caption. This describes what is occurring in this graph. Pause until you've figured out what you think the story is. Here's the story I came up with. The public feels most secure using landline phones and least secure using social media. All right, so very simple story. The bar graph really helps us make these comparisons. Here's another one. What's the story here? See if you can figure it out. Here's what I identified as the story. Bear population has more than tripled in 6 years. You see that the trend here is over time. A line graph is an effective way to do that. Again, what's the story here? This is a little more complex story. We're looking at 2 different spam filters. So here I have my story as filter A was more accurate, and I'm beginning with accuracy because I think accuracy is more important for a spam filter than speed. So filter A was more accurate but slower than filter B. This one you've seen before. And so the story, the way this is shaped, so this is a good example of using a bar graph to distinguish among groups. I think the way that we tend to interpret this is we focus here on Slovak males. So the story here might be Slovak males have the lowest test score, and this difference is most pronounced in school A. We have a secondary trend. There's more than one story going on here. So when there's more than one story, you need to prioritize what the story is. So the main point I want you to get from this part is that we need to tell the story both in the figure and in the words. Now, what are some ways to develop a figure, develop a visualization that tells a story? One of the key ways, and this is something that you will see a lot, everybody uses tables. They often do not use order in the tables to their advantage. Order can shape the story. Let me give you an example here. So this is from the 2008 Summer Olympics, and it is medals by country. Now, right now, the order is alphabetical. It's pretty hard to tell the story. So if I want to emphasize the story, I might sort it by the total number of medals. Now, what's the story here? Probably get the story is USA has the most number of medals. Now, look at the next one. I've sorted it differently. Now we have a different story. China is leading in gold medals in the U.S. Olympics. Incidentally, and I picked 2008 because this is a year where this was a controversy. This is the version of the Olympic medal data that appeared in U.S. newspapers. This is what appeared in the rest of the world. So just by sorting the table on a different column, I have a different story that is emphasized here. Okay, here is another example of some homicide rate data sorted alphabetically. Alphabetically is rarely the best way. It's best if you're going to use this chart to look things up. However, if you want to communicate a story, if you want to tell what your data means, alphabetical or chronological organization is usually not going to be the best way. So we could sort it. Obviously, one way is from least to highest. And so this jumps out that Maine, is doing the best, and Louisiana I kind of want to avoid. Now we can do some additional stuff to manipulate the story here and say what's most important. So we could do it by region. And now we're getting a little bit different story that's emphasized. We see the northern states, and I think I made up this data, so don't draw anything from this. So the north seems to have the best homicide rates. Looks like I definitely want to avoid moving to the south with a higher homicide rate. So I added a little bit of structure, changed how it's sorted, and we get a different story that is emphasized. When you come into the GCC, you will often see students who have tables that they haven't given any thought at all to how the data is organized, to how it's sorted. So this is one very simple thing that you can do to help them. Now, we can also think about using alignment and contrast to focus the story. You will often see tables that look like this. Oh, this drives me crazy. And don't do this in your own writing for me, please. So you see that some of these have decimal places, some don't. The way it's aligned, it's left aligned here. It is really hard to figure out which one has the most, which one has the least. So for instance, what I tend to focus on is the ones that go out the farthest. So I see Mississippi, California. Totally miss Louisiana as having the highest in here because it's not catching my eye. So we want to go ahead and align it like this previous one here. Much easier to see. Okay. All right. So this one, very hard to see the story. All I've done is aligned it, standardized the data, the decimal places, and it's much easier to see the story. There's a lot more I could do to emphasize the story here, but just lining it up by the decimal places makes it so much more readable. This is such an easy lesson to communicate that makes a big difference. So this is totally, I mean, it takes like, maybe 20, 30 seconds to explain, if that long, and it will make a big difference in the readability of somebody's data. So emphasize to standardize the number of decimal places and to align things so that it's lined up on the decimal points so that we can quickly identify the largest and smallest values, which is basic. This is just way too much work. I should not have to work this much. Now, we could further by adding a little bit of contrast, maybe using a little bit of color, emphasize the story on this a little bit more. So, for instance, we could do something like we could identify the winner and loser. And, of course, the story here now would be something like Firefox is faster on most tasks than Internet Explorer. We also want to think about getting rid of clutter that hides your story. So there's a principle called get rid of non-data ink. Any ink in a figure, a visualization, a table that is not communicating data is interfering with our ability to see the data. So take a look at this. We have all these boxes. That is a huge difference. I think it's a huge difference anyway. Much easier to see. All I've done is gotten rid of the boxes, and now it's much easier to make these comparisons across things. The non-data ink is competing with our visual attention. So here's some compressors that are sorted by efficiency. I get rid of the non-data ink. Much clearer. Here's another one, the state data, and just for you to see how much organization, how much cleaning things up, aligning things, adding some sort on here really makes a huge difference. Now, to get rid of these boxes in the tables, because you guys should know how to do this, so, and if you don't, go ahead and experiment with it. You can create a table, and then I want you to try to get rid of the borders, choose the borders. It is this little icon right here. That is the border alignment. So just in case students don't know how to do that. All right. So let's go ahead, and I'm going to switch now, and let's apply these same principles to bar charts. So again, tables are best for communicating detail, precision, but they don't really emphasize a trend as well as a bar chart. Or a line graph. Visual representations typically contain less data, but they really emphasize the trend. So if the trend is really important, the writer should put it into some kind of visualization. And conversely, if there's a visualization, something like a bar chart, a line graph, some other visualization, I assume that that is important to the writer. Otherwise, they would have put it in a table. So here's an example of, we saw this a little bit ago. I've ordered this by focusing on gender, race groups. And this tells one story, and it really kind of emphasizes and focuses our attention on the poor performance of Slovak males. Of course, in a graph this complicated, there are secondary, tertiary stories. So if I wanted to take this same data and emphasize the trend in schools, I could order it by the schools. And this really kind of brings into relief how school C is just terrible for everybody. And we see that in school A, the differences by ethnic group are most pronounced, in part because it's the highest performing school. School C is equal, but equal in kind of a bad way. It's equally bad for everybody. All right, so if I were to tell the story of this one, I would say school C has the lowest test scores, and then my secondary story might be something about race and ethnicity. Again, all I've done is just kind of flip the order in which we see things. All right, so this is a graph that I take from the website OKCupid, which is a dating site, and they do lots of analytics here. So one survey that they did is a percentage of OKCupid users stating that they would sleep with someone on the first date. Now, the way that this visualization is presented, it focuses our attention on women versus men. And we see that there are fewer women than men who would consider sleeping with someone on the first date. I'm going to argue that that's not a particularly interesting story. It fits in with all of our cultural narratives about sexuality. What is more interesting story is to organize it by those who like the taste of beer versus everybody else. And now this tells a very interesting story because we see that this is true for both women and men who like the taste of beer, are more promiscuous, I guess. And also we kind of really see that the number of women who like the taste of beer actually are more promiscuous, more likely to sleep with someone on the first date than the men who don't like the taste of beer. So that's very intriguing here. Again, just by flipping the order on which which axis things appear. So this is something that you can keep in mind when you're working with clients at the GCC. What if you flip the way that things are shown, changed what's in the legend versus what appears on the graph? Does it change the story, bring a different story into relief? So that was focusing on the order in which things appear. Just like with tables, we can use alignment and contrast in bar charts to focus the story. So this is comparing a control and experimental group from a pedagogical study on how their essays were rated. Right now we have kind of low contrast between the groups. This emphasizes the contrast a little bit more. I have put experimental. All right, this is the pedagogy that I want to advocate here. I've put experimental in a darker color in this one so it jumps out. And now we see the story just a little bit better. That experimental is consistently higher than control. Makes for a clearer story than this one. Same thing on bar charts. You want to get rid of the clutter that hides your story. Get rid of any kind of non-data ink. So this has a lot of non-data ink. It has all these lines on here. It has a gray background bar around it, box around the legend. Much clearer. Now we don't have a separation between the legend and the data too. And in general, you want to get this legend as close to the data as possible. You want to think when you have a figure like this, you want people to have the fewest eye saccades as possible. Eye saccade is how many times your eyes have to move back and forth in order to understand the data. So right here, we can see task 3, configuration in A and B did the best on task 3, a really big difference on task 2, trends reversed on task 1. It's not a really simple story here, but it's much easier to see the story. 3D data. 3D data always adds non-data ink. So right now, let's look at 1989. Is the level for like 1989 at 100 million? Is it above 100 million? Or is it slightly below 100 million? All right, I honestly can't remember. Okay, so the point here is obviously it's unclear which data point I'm supposed to look at. Do I look at the one in front or the one in back? Why have that confusion? Let's just go. Now we see 1989 is slightly below 100 million. It's right below that line. Now, in this case, you see how I've made the lines very faint, so it's not competing as much with the attention here in the with the data, but we still have it so that you can make some guesstimations on things. So in general, get rid of 3D unless that third dimension is actually communicating something additional, some additional point. Here's a graph that just does everything wrong. So we have 3D, we have these circle things that I don't know what's going on, busy background. It would also make sense to order, well, I guess if you have multiple ones, you want to keep the chart the same order, but we could order it from best to worst here. All sorts of problems with this one. Okay. Now let's go ahead and focus on line graphs. So where bar graphs are best for seeing differences among groups, line graphs are best for communicating trends over time. All right. So again, we can use order to shape our story. I call these spaghetti graphs right here. So we're seeing how the production changed between 1980 and 1990 for these different cities. When you have too many lines on the graph, in general, it's going to be kind of confusing. A really good way to break this is to make it into 2 graphs. And this is called the principle of small multiples. So with small multiples, we just break things. It's easier to see trends across two graphs than to have everything all in one graph. So we're seeing the U.S. here by foreign or non-U.S. In the other graph. Here's the same thing where we have a spaghetti graph here, and here we've broken it into two graphs to better see the story. Same thing with a line graph. We can use alignment and contrast to focus the story. So here, what's the story? A little bit hard to tell. I guess maybe the first thing I focus on is I'm like, what's this green line right here? It's non-U.S. men. Now you see that I have to do a little bit of work to kind of move from the graph to the interpretation. All right, so non-U.S. men have a pretty high graduation rate. I'm going to look at the lowest. That's U.S. men. I made up this data, by the way. But it's hard. I'm not sure what the author wants me to focus on, what they see as the main news. So, whoops. Here we go. Here's the same data. Now there's no doubt what trend the author wants me to focus on. Clearly the focus is on the poor performance of U.S. men, and I've used contrast to focus this, and you see how I've lined up, instead of having a legend like this, I've lined things up so I don't even need a legend here, and it is much easier. I don't have to work as hard to figure things out. Okay, here is another graph. Very hard to figure out the trends here. Again, with some contrast, we can make a much stronger graph. For some reason, I don't have a revised version of that one. With line graphs, again, we want to get rid of non-data ink, anything that hides the story. So try to get rid of busy backgrounds, grid lines. Here is the same graph, and now we kind of see this big peak and drop off becomes much clearer, much more visible, much more in your face. We see the shape much more when the background is not competing for attention. Here's another one. Again, get rid of all this is just terrible. Here the background is overwhelming the data. Okay, so I have a handout for you all with some examples on it. And I want you to go ahead and work through those examples and think about how you might improve the visualization. And then we'll look at those. I have one more point that I want to make, which is to use pie charts sparingly. Pie chart, let's just put one up here. They're cute. That's the best thing we can say about them. They're colorful. They are good if you have like a small number of items on here that you want to give someone a sense of the proportion. But it's very hard to match this data up. So if I ask you how much bigger is company A share than company E? Okay, I don't know, 10% bigger. It's really hard to make these comparisons. It's also not clear. Are you seeing things as larger because they're a darker color? So color can kind of interfere. Now we could make this a lot easier to see if we put labels on here. We still have to do a lot of isocods to figure out to match things up. So we could put the information like this. Now I have the company and the percent here, and now I can make these comparisons. And what I've basically done is created a table that I've put in a circular format. If I'm going to do all this, I might as well just put it in a table. And now if I ask you how much bigger is company A than company E, wow, I guess 10% bigger before. It's 3%. So pie charts are very inaccurate. For most of our students in technical disciplines, pie chart, it actually competes with their ethos. In a technical discipline, it's really important to project yourself as accurate, as precise, and pie charts go against that, ethos. Now, in business, in a CEO maybe type context where you're presenting to shareholders, it's a more public thing. If you have a very simple story to make and you use a pie chart, that might be appropriate. But in general, pie charts are really difficult. It's very hard. Edward Tufte, who is kind of the big name in data visualization, that's Tufte, T-U-F-T-E, says the only thing that's worse than one pie chart is two of them. And if you want someone to make comparisons across things, so which military branch grew the most, this is very hard to do with a pie chart. If we do something like this, we see that, between 1990 and 1998, we see that most shrunk here in 1998, so none of them really grew a whole lot. Okay. You definitely don't want a 3D pie chart. Wow, this is, I guess this tells you that the three things are equal, more or less. But whenever you have a 3D pie chart, it's also whatever's in front is going to look bigger. Just never ever do this. Okay. Hopefully I've made that point clear. All right, so to sort of wrap this up, I want you guys to do the exercises on the attached handout. I also want you to go back to the IMRAD reports you created for me and redo the visualizations. I don't think nobody had a particularly good visualization for that data. So figure out what's the story you want to tell and what visualization would be the best. You can just draw these by hand. I'm not looking for anything fancy. But I want you to think through this, and I also want you to do a quick informal writing of what you learned and how you're going to apply this to tutoring practice. Okay, see you guys in class.